In this video, we're going to talk about why it makes sense to invert and multiply when we're dividing fractions. So in the textbook, we have this problem. Oliver swam 3/5 of a mile in 2/7 of an hour. If Oliver keeps swimming at this pace, how far will he swim in 1 hour? The way we solved it is using this picture. We drew a picture of what 1 hour looked like. We were very careful to match up 3/5 of a mile with 2/7 of the hour, and we used that information to fill up the entire hour with miles. There are many ways to think about what's happening here. The one that we want to choose in this particular video is really making use of our meaning of fractions. So what we have here is this 1 hour cut into 7 equal pieces, and 2 of those pieces are shaded. So if we look at this shaded region, we can see that that's 2/7 of the hour. And we know that 2/7 of the hour is exactly the same thing as 3/5 of a mile. So if we take a look at what we have here, if we look at our original picture, we're thinking about our hour as our whole. So the entire box is the whole. And that's what makes this shaded region 2/7 of the hour. But what we're really trying to do is actually think about what's happening for the entire hour using what's happening just in this shaded region. So instead, to solve this problem, we want to think about the shaded region as our new whole, and then the entire hour as our new part. The part, remember, is the thing we count to get the numerator, and the whole is the thing we count to get the denominator. And so if we look at this fraction, swapping the roles of the whole and the part, so here the whole was the hour and the part was the shaded region. Here, the whole is the shaded region and the part is the entire hour. This 2/7 of an hour that was the shaded region becomes our new whole, and so this is cut into 2 equal sized pieces. And the part that we're trying to count is 7 of those 7 copies of one of those pieces. So 7/2 of the shaded region. So when we switch the role of the whole and the part, we're actually swapping the numerator and the denominator. We've flipped this fraction 2/7 upside down to be 7/2. And the reason this works really nicely for us is that we know how many miles are in the shaded region. So I need to make 7/2 of the shaded region, 7/2 copies of the shaded region, and that making copies is a multiplicative structure. So I know that I'm taking 7/2 copies of the shaded region. I have 3/5 of a mile per copy of the shaded region. And then that's going to give me my answer, which in this case is 21/10 of a mile. So looking back at our original problem, we were trying to solve 3/5 divided by 2/7. And what we ended up doing was we took this 2/7 and we flipped it over because we exchanged the role of the numerator and the denominator. And then because we were trying to make copies of this 3/5 of a mile, we ended up multiplying 7/2 times 3/5. Now, of course, normally the way you probably see this written down is in the opposite order as 3/5 times 7/2, so that we can have our keep, change, flip, if you like to think about it that way. But of course, the commutative property of multiplication tells us that we can write the two factors in either order and we get the same answer. So since we understand where this 7/2 times 3/5 comes from, we also can see that this problem is solved by doing 3/5 times 7/2.